So let's start. Okay, so in previous lecture, which was last week, we have discussed up until the nomenclature of alkenes. Okay, so basically to name alkenes compound, or basically to name compounds, organic compound, we have to follow the steps that IUPAC have set for us. Okay, so basically we have 5 basic steps that we need to take note before we name any organic compound. Okay, so the focus for last week was for alkenes. Okay, so basically we have 5 steps. First, you have to identify the longest parent and the longest and continuous parent chain. Okay, and then the numbering, and then the naming. The numbering, and then assign the substituents to get the lowest numbering as possible. Okay, and then the naming itself. Okay, and then you have to consider in terms of prefixes used. If we have 2 methyl group on the parent chain, you have to add in di as the prefix. Okay, dimethyl. If you have 3 ethyl group, for example, so you would be using triethyl. Okay, so those kind of thing. And then to separate numbers and alphabet, you have to use hyphen, okay, dash, and to set if you have more than one substituents or the same alkyl group, you may need to use comma. Okay, so those kind of thing you have to be aware of, because if any of those missing in the names, definitely marks will be deducted. Okay, so it is compulsory for you to follow all the steps in order to get the correct name of the compound. Okay, all right. So basically the most part of it we have covered. Okay, during our last lecture, we have a little bit more on the nomenclature that we haven't managed to cover during our last lecture. Okay, so we are going to cover it now. Okay, just very small part of it. Okay, all right. Some of the branch chain alkyl group also have non-systematic common names. Okay, so the one that we have the rules that we have gone through is to give the compound a systematic name. Okay, so rules yang kita dah cover tu is to to name the compound systematically, ataupun systematic names lah for the compound. But you also need to know that it can also be named non-systematically. Okay, ataupun can also be called as common name. So some of the common name ataupun this non-systematic name have been acceptable and have been used as IUPAC naming style. Okay, all right. Contohnya 3 carbon alkyl group. Okay, if we have only 3 carbon, that means is the only carbon chain that we have, then it is called propane. Okay, dia tak ada substituent, tak ada apa, so it is called propane. Then if these 3 carbon alkyl group become substituents, imagine we have a longer parent chain here, so this substituent becomes, this alkyl group now become a substituents, then it will be called as propyl. Okay, so YL stand for represent the substituents. So if we have 3 carbon atoms, that means it would be called propyl. That means, okay, the first of alkyl group, the first of propyl group is attached to the parent. So this is the parent. So the parent is attached to the first carbon of propyl group. 1, 2, 3. Okay, then it is called propyl. Okay, what if, okay, the parent, so this is the parent, and then this is the branching, okay? So the parent is attached to carbon number 2 of propyl group. So what is it called? Takkanlah nak panggil propyl. We cannot call propyl because propyl is called if the parent is attached to the first carbon of the 3 carbon alkyl group. Baru dia panggil propyl. If it is attached to second carbon of the propyl group, then it is no longer propyl. It is called isopropyl. So this is the non-systematic name. Later, we will look into how to name this isopropyl based on systematic name. So kita ada 2 option. Okay, so we are going to discuss the non-systematic name first. Okay, so it is called isopropyl. Okay, all right. The reason it's called YL because again, this is a substituent. Dia punya branch, dia ends with YL. And the reason it is called propyl because in total, we have 3 carbons in it. And the reason why it is called iso is because satu, dia attach kepada carbon number 2 in the propyl group. And then iso, okay, you familiar dengan iso kan? Iso means ada something yang sama, like isomer kan, something yang the same. So in this case, yang sama adalah methyl group. This carbon right here is attached to 2 methyl group. Okay, it's like kalau saya kembangkan, dia jadi begini. CH3, CH3, okay, and then ada H. Then you have the parent. So this CH3, CH3 represent the iso. Iso represent this same methyl group. Iso represent this same methyl group attached to the carbon that is directly attached to the parent. Okay, alright. Isopropyl. Okay, kalau dia attached to carbon number 2 of propyl group. Okay, what if we have 4 carbon alkyl group? Okay, so if we have 4 carbon alkyl group, if that is the only chain that we have, that means it will become the parent lah. So it is called butane. Okay, all right. What if this butane become substituent? So imagine we have a parent chain here, longer parent chain here. So this would become substituents. When this becomes substituent, this 4 alkyl group carbon becomes substituent, then it is called butyl. Okay, so please take note that it is called butyl because it has 4 carbon, 4 alkyl group carbon, and the first carbon is attached to the parent chain. So we have 1, 2, 3, 4, straight chain. Okay, so it is called butyl. Okay, alternative to this butyl, we can also have sec butyl. Okay, third butyl, sec butyl, third butyl, and isobutyl. Okay, all right. So similar to propyl group just now, if the second carbon is attached to the parent, so this is the parent kan? Okay, so the second carbon of butyl group here, it is still called butyl because it has 4 carbon in it. 4 carbon. In total, we have 4 carbon. But it is no longer just butyl. It is called sec butyl because this second carbon in the butyl group is attached to the parent. And this second carbon also is a secondary carbon. Okay, because this carbon is attached to this one and this. Okay, ignore the parent. Ignore parent tu memang dia parent lah. So just focus on this carbon. So this carbon, dia punya status dia tu, dia punya degree of carbon is secondary because this carbon is attached to, in the group itself, in the substituent itself, it is attached to first and second carbon. Sorry, is attached to 2 other carbons. And therefore, it is called sec-butyl. Okay, sec-butyl. Alright, alternative to this, we can also have in this form. Okay, in this form, it is called isobutyl. So if this is the only chain that we have, therefore it can become what we call that, can also be the parent. Okay, it can also be the parent. Okay, if normally if we would name this based on systematic naming ataupun follow IUPAC yang we have learned earlier, we would call this as dia punya the longest parent is propane, right? Propane kan? Propane. 1, 2, 3, and then at carbon number 3, we have methyl group. So 2-methyl propane. Ni nama systematic name dia. Tapi it can also be called as common name. Okay. Ataupun commonly known as isobutane. Dia ni ada 2 nama lah. Okay. In an industry, industry prefers to call this common name rather than this IUPAC name because dia pendek. Okay. Kalau IUPAC, you have to consider in terms of numbering, in terms of the location and whatnot. But common name is very straightforward. Tapi provided you have to know lah why is it called isobutane. Okay, alright. So okay. So let's look at if they become substituents. Okay, they become substituents. So this is the parent. Ni parent dia kan, longer parent chain compared to this substituent. Okay, so the reason it's called isobutyl is because of dia dalam substituent. This is substituent. In the substituent, we have another substituent. Nampak tak? This is already substituent. So in this substituent, we have substituent. Yang ni substituent ni. Okay, alright. So this is isobutyl. Again, kenapa it is called iso? Because we have 2 methyl group attached to the second carbon of butyl. Butyl. Okay, dia dipanggil butyl because in total we have 4 carbon. That's why it is called butyl. Iso, okay, iso is because this carbon number 2, starting from the one that is attached to the parent. So this is carbon number 1, number 2. So this second carbon is isomer. Isomer pula. It is methyl group, same group lah, similar group attached to this carbon. Therefore, it is called isobutyl. But it is, you have to take note that before this carbon, dia ada satu CH2 dulu. CH2 and then C and then CH3, CH3. This looks the same as propyl just now. Betul tak? Nampak tak? Isopropyl just now. That's why nama dia isobutyl pula sekarang ni. Okay, dia ada CH3 and then CH3 ada H. Tapi this is for butyl, you have to have CH2 before this carbon. Okay, so this is isobutyl. Okay, last one for this 4 carbon alkyl group. We have third butyl. Okay, third butyl. So imagine this is the parent. So this is the parent. So this parent is attached to this carbon. Okay, the reason it is called butyl again because we have 4 carbon in the substituents. We have 4 carbon in the substituent, and then the reason it is called, it starts with third because third is the short name for tertiary. Sec is the short name for secondary. Third is for tertiary. Tertiary. Okay, so third butyl because this carbon, the one that is attached to the parents, okay, the one that is attached to the parent is a tertiary carbon. Because, nampak tak dia attach kepada 3 carbon in the substituent. So therefore, it is called third dash butyl. And this sec and third should be in italic form. So ini dia sangat italic form. Okay. Alright. Tapi when you later, when you want to add into the full name of the compound. Okay, remember kan kita kena consider for the alphabetical order kan. You are going to consider for the B, not for the T and S. Okay, all right, take note. One thing that I want to make sure that you are aware of, okay, that for alphabetical order, later on when you try to combine this substituent into the full name of the compound, okay, kita nak kena consider the alphabetical order kan. So kita akan consider kalau Cyclopropane dash, we are going to consider this B, not this S. Okay. Same goes to third butyl. Okay. So kita akan consider the B. Maksudnya B ni dia akan duduk yang terawal lah. The nama dia tu akan duduk paling depan. Sebab dia B kan, after E. Okay. So we are going to consider for B instead of for T dengan S. For sec and third. Okay, please take note on that. But how about for isobutyl? For isobutyl, you are not going to consider for B, you are going to consider for I. Sebab dia mungkin satu nama kot ni. One word kan. So we are going to consider for I, not for B. Okay, isobutyl dia special sikit. Kita akan consider starting dia ni sebagai I, bukan sebagai B. Okay, alright, done with that. Okay, you can imagine kalau kita ada 5 carbon alkyl group, so we can have more than the 4 carbon alkyl group punya common name. So the more carbon we have in the substituents, the more common names that we may possibly have. Okay, so that's why kita cover sampai 4 carbon je. Kita tak cover sampai 5 carbon, 6 carbon and whatnot, and so on. Okay, alright. So that is in terms of non-systematic naming. Okay, what if you would like to choose for systematic naming for the substituents? Okay, so how would you name the substituents? So this substituent, this type of substituent, okay, just now, is considered as complex substituents. Kenapa? Because dia sebagai substituent, dalam substituent tu ada substituents lain. Okay, so that's why dia kata complex substituent. Okay, so how will you name it systematically? Okay, let's consider this compound. Okay, guys. Okay, so macam biasa, kita have to decide on the parent chain. Okay, the longest and continuous parent chain. So we will get the red one here. Ni dia dah assign lah, siap-siap. Okay, you identify. So you get 10 carbon in this parent chain. Therefore, it is called decane. Okay, and then next we would identify the substituents. Okay, kita identify, okay, these 3 will be the substituents. These 3 will be the substituents. Okay, so of course, obviously, we are going to start on the left-hand side. Sebab dia berat, nampak dia punya berat dia tu dekat sebelah kiri. Okay, so numbering will be the lowest if we start from the left to the right, rather than from the right to the left. Okay, all right, so this is not a problem because we can call it methyl directly. Okay, we have 2 methyl there at carbon number 2 and number 3. So that's why we have 2,3-dimethyl. Okay, all right, carbon number 6 here, we have these complex substituents. Okay, how would you name these substituents? Okay, all right, based on common name just now, this would be called isobutyl. Okay, because we have CH2. And then C, this C is attached to 2 other methyl group. So this is isobutyl. If it's called common, if it is named based on common name, it is isobutyl. Okay, how do we name based on systematic naming style? Okay, let me just clear everything off first from this. Okay, let's have a clean slide. Okay, all right. So you would name it as if macam you name for normal compound, for a normal compound. Okay, you separate this one. Okay, so you take note that this would be attached to the parent, so you separate this. Okay, so you would name this based on normal compound. So you would choose, okay, you would go for the parent chain. Okay, even though this substituent, you akan go for the parent dulu. Okay, so from this parent, so you're going to start here. Here will be the first carbon. Because why? It is attached to the parent. Okay, so this will always be carbon number 1. Okay, so kita kena cari, first step is to find the longest and continuous parent chain, starting from this carbon 1. So the longest will be this one lah, yang obvious. You boleh juga buat ke atas ni, boleh. Asalkan the longest continuous. Tapi you still akan dapat at carbon number 2, we have this methyl group ataupun this methyl group. Okay, so I'm just going to choose the straight one. Okay. Okay, so this would be the parent of this substituent. So we have 3 carbon, right? So it is called propyl. Ha, nampak tak? It should ends with YL because it is a substituent. Dia bukan propane. Propane yang in ni dia adalah parent yang sebenar, the original. Okay, but this one ends with YL because it is a substituent. It's just the approach is the same as how we would name for the original compound. Okay, so this is propyl because it has 3 carbon, and at carbon number 2, we have this methyl group, right? So it will be called 2-methyl propyl. So this isobutyl common name can be named systematically as 2-methyl propyl group. Okay, all right, so this is the systematic name. So how should we include this systematic name into the full name of the compound? Okay, so we are going to consider for the numbering is not a problem sebab kita akan start numbering here kan. So we would get carbon number 2 and carbon number 3. So number 2, number 3 and number 6, right? So 2 to 2, 3, 6. But carbon number 2 and number 3 are methyl group attached to them. So we have 2,3-dimethyl. Don't forget the prefix. Okay, so at carbon number 6, we would have these 2-methyl propyl. So to differentiate the normal substituents with these complex substituents, we would have this bracket. You need to have the bracket. Okay, you would use this bracket. Okay, tapi macam ni macam confusing kan? Okay, kita akan consider macam ni. Kita tak consider this because of dia di, dia duduk depan. Bukan. Ini prefix. Kita akan consider methyl M dengan this one also M juga. Betul tak? M dengan M. So, methyl dengan methyl lah basically. Okay. So, who will go first? In this case, kita akan prioritize the numbering. We will go for the lowest number. Since both of them also pun methyl. Okay. So, 2, 3 dengan 6 mana yang come first? 2, 3 lah. Okay, that's why 2, 3 dimethyl dash 6 dash bracket, guys. Okay, for the complex substituent, 2 methyl propyl and then decane. Okay, all right. So this is if it is named based on systematic. Okay, or we can also name based on common name. Okay, so this is how it is named. As you can see, okay, so dia berbeza sikit lah ni systematic dengan common name. Sebab kalau if you are using isobutyl, that means you have to consider for I. I dengan M, siapa datang dulu? Bukan dia, saya cakap lagi sekali, bukan D. Kita consider substituent tu punya nama. Ini hanya substituent. Ini prefixes. Okay, prefixes yang kita guna untuk nak menggambarkan to represent the numbers of substituent present in the compound. So kita tak based on D ni untuk alphabetical order, kita akan based on the name of the substituent itself. So I dengan M, I come first kan. So that's why 6 isobutyl, 2, 3 dimethyl Dk. Okay? Alright, so let's look at another example. So this is another example that we have. Okay, let's have other color, other ink. Let's have green. Okay. Okay, ini lebih straightforward lah. Okay, so identify the parent chain. So the straight one will be the parent. 7. Okay, so it is called heptane. Okay, this one kita hilang typo heptane. And then this would be the substituents. Okay, so we have 3 carbons of alkyl group. Therefore, it is named as, it is not propyl. Kalau propyl, dia mesti attach kepada carbon number 1. Ni dia attach kepada number 2 carbon in this propyl group. Okay, alright. So if you are using common name, it is called isopropyl. Okay, nampak tak dia ada 3 carbon, that's why it is propyl. Iso because this carbon yang attached to the parent is also attached to 2 same group, which the methyl. Okay, which is a methyl group. Okay, this is based on common name. So how do we name based on systematic, guys? Sama sahaja, we are going to choose the parent. Okay, so this will be carbon number 1. So since dia macam terpotong kan, remember nak choose the parent, you have to go for the longest and continuous. So if this is carbon number 1, you can either go to the right ataupun to the left. Okay, so katakanlah saya pilih ke kanan sini. So 1, 2. Dia tak boleh 1, 2 patah balik ke sana. Itu dah terputus. Tak boleh, dia kena continuous. 1, 2. So we have 2 parent chain for these substituents, right? So if we have 2 parent chain, 2 carbon in the parent chain, then it is called ethyl. Okay, dia ends with YL because here adalah substituents. Okay, in this substituent, we have 1 substituent attached to the first carbon. So it is written as 1-methyl ethyl. Okay, 1-methyl ethyl in the bracket, and then this whole group is located at carbon number 4, right? So we have 4 dash bracket 1-methyl ethyl heptane. Okay, all right. Yep, that one. Okay, any question related to the common name just now? Normally, student will go for this complex substituents punya systematic punya naming. Okay, sebab apa? Sebab dia somehow this method is more familiar. Okay, dia because it's actually the same approach that we have for naming the compound yang kita ada 5 step tu. Dia basically dia sama, cuma dia ends with YL je. Dia complex substituents. Okay, if you are going for this one, that means you kena remember lah. Okay, you have to memorize how it is the structure of the sec butyl, the third butyl, isobutyl, and isopropyl just now. But okay, please take note that you also need to know lah. Memang in a way you kena memorize lah juga for this one. Because why? In case in the exam, the question asks you, okay, please name this common name. Ataupun please draw the name given. So kalau you tak tahu sec butyl tu apa, how will you draw the structure? Okay. Tapi kalau dia suruh name the compound, you have 2 options there. You may use this method, the systematic punya style, ataupun you may go for the common names. Okay. Okay, maybe we can try out A. Okay, we can try out question A. Okay, give IUPAC name for the following compound. Okay, let's do it together. Okay, guys. Okay, so kita kena start from the beginning. You have to identify the longest parent chain. Okay, the obvious. Okay. Okay, kita kena check. Kita kena try and error. Okay. Normally student akan go for the obvious. Tapi yang tak obvious tu kadang-kadang maybe the answer. Okay, yang paling obvious dia nampak macam panjang aja. Okay, kita tak apa, kita calculate. Kita totalkan, kita count the number of carbons. So we have 1, 2, 3, 4, 5, 6, 7, 8. So if we calculate based on this straight chain, we got 8 carbon. How about if we calculate from the top to bottom? Okay, before you go for the naming, I would highly suggest you to expand everything. At least for the carbon lah. Okay, because this one you mungkin tak nampak dia substituents ke apa kalau dalam keadaan bracket macam ni. So I would highly suggest you to expand. Tak adalah expand dia tu hydrogen tu nampak dia punya bond, tak perlulah sampai macam tu. Macam ni. Okay, so this one, this CH3 is attached to this carbon, right? So we have 2 CH3 attached to this carbon. So as if macam dia ada 2 CH3 macam tu. So yeah. So saya delete yang ni lah sebab saya dah kembangkan dia. Okay. So this is how it looks like. Yeah, and ada satu H dekat situ. Okay, so kita nak apa nama tu, nak numbering, kita nak start from here lah. Saya start from atas. Boleh juga daripada sini, daripada bawah naik atas turun pergi ke sini. Remember, longest and continuous. Okay, alright. So this one, saya start from here, going down, and here. Nak ke bawah pun boleh, either one either one. Nak ke kanan atau ke bawah. Continue. Oh. So how many carbon do we have for this one? 1, 2, 3, 4, 5, 6, 7, 8. So still we got 8 carbon. So kita ada 8 carbon dengan 8 carbon. Okay, be careful. Looks like dia ada the same number of carbon. Next, we need to consider the number of substituents. Banyak consideration yang you kena take into mind. Maksudnya you have to you kena consider lah all these things. Okay, it's not as simple lah because the molecule itself can be complicated, besar, bulky and complicated. Okay, so you kena go through the steps to very carefully. Okay, if we start from here, from top to bottom here, you akan dapat berapa substituents? Let's count. Okay, berapa substituents? Okay, so we have 1 substituent. This one substituent, betul tak? Yang hijau ni parent And then another one would be this one, the beta group at carbon number here. We have 3 substituents. 3 substituent. Ni benda-benda yang you kena consider. What if kalau you start from yang straight ni, yang 8 carbon yang tadi earlier, yang the first one, initial one tadi, kalau you start from this one, okay, kalau saya buat bulat macam ni saya merahkan. So you ada hanya berapa substituent? This one, yang giant ni, and this one. You hanya ada 2 substituent. Even though they both have the same number of carbon, but they have different number of substituents. So we would go for the one that have more substituent, which is this one, not this one. Faham? So ini benda yang you kena consider lah bila you buat naming. Okay, kena banyak try and error. Okay, let me just clear everything off first. Okay, so this tadi saya extend, saya kembangkan. Okay, saya delete. Okay, so kita punya parent will be this one. Longest and continuous, okay. Sorry. Okay, so kita punya substituent will be this one. So we have 1, 2, CH3 here, and then this one. Kita tahu kita ada 3 substituent. Now, kita nak buat numbering pula. Okay, so how should we number these substituents? Ada 2 option juga. Either we start from here ataupun kita start from here. Okay, alright. So the tips is to go for as lowest number as possible for all the substituents. Okay, tak apa. Kita start. Okay, let's say kita start from here lah. From left to right. From left going up. Okay, so kalau kita start from there, 1, 2, 3, 4, 5, 6, 7, and then this is the 8 carbon. Okay, so kalau start daripada sini, kita akan dapat 2. Carbon number 2, kita ada methyl group. And then carbon number 5, is it? Number 5, we have this propyl group here. And then next, we have this one at carbon number 7, right? 257. Okay, 257. Okay, what if we start from here? Pakai color lain so jangan confuse lah Kita start from atas ke bawah. Tadi dah start from here kan? So kita start dari atas ke bawah. So saya numberingkan balik. 1, this is carbon number 1. This is carbon number 2. Number 3. Number 4. Number 5. Number 6. Number 7. Number 8. Okay, alright. So kita dapat dekat carbon number berapa yang ada substituents. Ni macam pening sikit Padam. Nak padam malas tadi. At carbon number 2, we have this methyl group. 2. And then we have a carbon number 4, is it? Right? Kalau kita start 1, 2, 3, 4. Ya, carbon number 4. And carbon number 7. We have 247 and 257. So, which one is the lowest? We will go for this one, not this one. Okay? Right, so 247. Now we are going to name the compound. Okay, alright, so kita kena identify. Let me bagi clear everything dulu. So mana tadi buat balik. Okay, CH3, CH3. So ni tak pakai dah. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is methyl. This is methyl. And this one yang panjang sikit ni. Sorry, daripada sini. This is propyl because we have 3 carbons. Okay, alright. So at carbon number 7 we have methyl. Carbon number berapa tadi? 2. Okay, this propyl is at carbon number 4. Okay, so nak namakan. Okay, we're gonna start with the parent first. Tadi ada 8 carbon kan? Ada 8 carbon in total from top to bottom. So it will be known as octane, guys. Okay, alright. So kita ada propyl dengan methyl. P dengan M. Mana come first? M datang dulu. Okay, bukan based on numbering Kita base bila nak letakkan sebagai nama, kita based on alphabetical order. Okay, alright. So kita ada 2 methyl group at carbon number 2 and 7. So 2, 7 dash, don't forget the prefix because we have 2 number here, then it should be di. We have 2 methyl group kan, dimethyl. And then we have propyl group at carbon number 4 here. Okay, dash 4 propyl. 2,7 dimethyl 4 propyl octane. Okay? Ya, begitulah ceritanya. Okay, alright. Maybe we can try another one. Let's try D. Okay, so let's try D. So let's expand everything first. All the condensed form, let's expand so that we can see everything and to make sure that we did not miss anything at the end. Okay, alright. So yang ni nampak macam dia dah condense kan? Okay, let's expand. So dia ada 3 methyl group attached to this carbon. So we have CH3, then another CH3, right? Okay, ni dah tak ada lah. So sebab saya dah kembangkan CH3, CH3, CH3. Okay, alright. So ini dah memang quite obvious lah ni. Yang ni yang straight. Tak apa, kita just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So kalau kita count the straight chain, yang paling obvious would be 10 carbon. How about if we start from top to the right? Top here. to the right. Nampak macam panjang kan? 1, 2, 3, 4, 5, 6, 7, 8, 9. You only have 9. Okay, how about this one? Turun bawah. Ni sikit. 1, 2, 3, 4, 5, 6. Okay, kita ada 10 carbon, kita ada 6 carbon, we have 9 carbon, so the longest will be 10 carbon. So ni lah. This will be the parent. Kena try, kena try. Kena zigzag ke, atas bawah ke, tepi kanan kiri ke, as long as the continuous and the longest. Okay, alright, so the parent would be called, I write the name here, okay, Alkene, because it has 10 carbon. Okay, so we have 2, therefore we have two substituents in the attached to the parent. Okay, so this one and this. So ni pun quite obvious. We are going to start numbering from this side, from the left side, 1, 2 to the right, 3, 4, 5, and so on. Okay, so at carbon number 3, we have this ethyl group. This is ethyl group because we have 2 carbon only. And this one, nampak tak? This is complex substituents. Dia bukan butyl lah. Butyl dia akan straight je. 1, 2, 3, 4 carbon. Ini bukan ini dia derivative of butyl. Complex substituent just now. Okay, ada 2 option. So, we would go for common name. Okay, this substituent is known as apa ni? Kalau ada 3, this carbon is attached to 3 other methyl group. What is it called, guys? Kalau common name just now.
Third butyl.
Yeah. Third butyl. Third butyl. Because this carbon is attached to another 3 carbon in the substituents. Not including the parent. Kalau masuk parent dah jadi quaternary. That's why saya kata tak termasuk parent. Okay. So, this is third, guys. Third butyl. This is a common name. Okay, how would you name based on systematic naming? Okay, alright, so nak pakai kali lain, kali hijau. Okay, so you're going to start from the carbon that is directly attached to the parent, right? So this one. So this will be carbon number 1. Okay, so dia terbelah, dia sebab yang continuous, remember? So carbon number 1, you either go to the right, okay, go up ataupun go to the left. Tapi either way pun you boleh pilih mana-mana, you akan tetap dapat 2 carbon saja. 1, 2. Okay, 1, 2. Dia punya parent will be 2 lah. You nak naik atas pun sama, 1, 2. Okay, the rest will become the substituents for these substituents. Okay, so this will be substituent and this is another substituent attached to the same first carbon. Okay, so dia punya systematic name will be, so ethyl lah parent dia. Sebab dia ada 2 carbon kan. And at carbon number 1, we have 2 methyl group. So, 1, 1, see, because you have 2 methyl group kan. Dimethyl. 1, dimethyl. Ethyl. Okay. Alright, so this is the common name. This is the IUPAC name, the systematic name. Okay, now we are going to put this into the full name of the compound. Okay, so we have 2 option lah. 1, kita go for common name. Kita akan buat 2-2. Okay, let's go for common name first. So at carbon number 3, number 3 kita ada ethyl kan? And then this one at carbon number 4. Okay, alright. So kita go for common name dulu. Kita go for common name. Kita compare B dengan E. Siapa datang dulu? B dengan E. B lah datang dulu. Okay, alphabetical order. So at carbon number 4. Carbon number 4 kan? Okay, sebab B datang dulu. 4. Third butyl. Ada dash, sorry. Aduh. Dash kan, dash ni tak boleh tinggal tinggal. Sebab dia dah ada, dia kena follow format, exactly the format. third butyl, and then at carbon number 3, in the parent chain, we have ethyl group, right? Dash 3 ethyl decaying. Okay, all right. Alternative to this, we have the systematic naming style. Mana tadi? Satu-satu dimethyl. Okay, we are going to be based on M lah. M versus dengan E. Siapa yang menang? E lah menang. E will come first. Okay, alright. Therefore, E akan ditulis dulu. So, 3 ethyl E dash. Okay, this one you have to have bracket. Okay, guys. These complex substituents, third butyl ni. Okay, kalau nak namakan systematic naming, you have to use bracket. Okay, so numbering kat mana? At carbon number 4, right? Okay, dash. Don't forget the dash. And then bracket. 1, 1, dimethyl. Close bracket. Decay. Okay. Ni lah nama dia. Dua-dua pun acceptable. Okay.
Madam.
Yep.
Dia tadi dimethyl ethyl ke dimethyl saja?
Dimethyl dimethyl ethyl tinggal. Potong. Okay, buat balik lah. Sempit kan tempat sebab kita buat dah parent, lepas tu kita start from depan. So dia nak agak ruang dia tu. Apa tadi? 1, 1 dimethyl ethyl. Okay, keluar sikit. Okay, 1 dimethyl decay. In the bracket, okay, hilang bracket, hilang markah. Okay, alright, so maybe you can try on your own for B and C. Kena try ini kena try sebab you nak dapatkan dia punya skill tu. Kalau tak mesti akan tak habis-habis nak okay, mesti ni dia punya parent. You kena try, you kena macam ni. Ataupun this one going down, ataupun this one macam ini. Kena try. Okay, kena try and error. Betul tak? 2,7-dimethyl 4-propyl octane, 2,7-dimethyl 4-propyl octane. Last one, 4 third butyl ni. This one we don't have this bracket lah. Okay, tak perlu bracket because this is common name kan. 4 third butyl 3 ethyl decay. Sama tak dengan saya bagi tadi? 4, this one yang atas ni 4 third butyl 3 ethyl decay. Sama. Okay. And then we have another checkpoint. For this one, you have to draw the skeletal structure. Okay, so from the given name, you have to draw the skeletal structure. I find it easier if we have given the name and then we have to transform into the structure. It will be easier sebab kita akan go for the parent dulu, kita buat parent and then kita just buat branching. Kita count the number. We assign the number on the parent chain and then kita terus assign, oh ada 2 methyl. Okay, I find it more easier. I find it easier compared to this type of question. You have to name the compound. Sebab banyak sangat consideration that you have to take into mind. Okay, so you kena aware lah. Tapi kalau this one, this should be easier. You just transform this into the structure. Okay, you normally go for the parent dulu. Then you have the parent. Okay, and then you are going to number the carbon, and then you assign the substituents dekat the carbon. Okay, alright. So try this one also. Ayo. Itu 2 slide dia sampai dekat sejam. Okay guys. Tapi dia naming ni dia tak banyak lah soalan. But it is necessary. Okay. So the most important part in organic chemistry is the reaction sebenarnya. But as you can see and as you can refer from your slides, dia punya slide covered for nomenclature is quite a lot. Tapi that is at the beginning lah. Later on, for each functional group, okay, ada naming style dia. One good thing about this long slide, maksudnya banyak slide dekat di beginning adalah these rules will be adapted in the nomenclature of other functional group. That's why lah masa awal-awal tu banyak sangat kita bagi use apa nama tu, dia punya steps, okay, dia punya consideration that you have to take note before you could name a compound, because this later on will be adapted in naming other functional group. Just a few modification lah, ada alteration part saja, sikit je, very minor. Okay, but you are still going to adapt the method, the approach that we have learned earlier for the naming. So that's why tak habis-habis naming ni. Okay, let's move on to cycloalkenes. Okay, cycloalkenes, that means the carbon atoms in the molecule are arranged in the form of a ring. Okay, in the form of a ring. So just now it is an open chain. Those are open chain. The one that we had earlier are all open chain. Maksudnya terbuka chain dia tu. But this one dia punya carbon meet carbon. Okay, dia cyclic in a form of ring. Okay, right. So this one is called cyclopropane. You have to have a prefix there to represent the cyclic version. So it is called cyclopropane. It is called propane because it has 3 carbon. It is called pentane because it has 5 carbon, but it is in the form of ring. Therefore, you have to have cyclopentane, cyclobutane, cyclohexane, cycloheptane, cyclooctane, and so on. Okay. Naming juga. Okay, so very quickly, okay, so basically dia punya step dia sama, it's just that there are few highlights that you should know, okay, that I would like to highlight here. Okay, find the longest parent hydrocarbon chain. Of course, you're gonna find the longest. Okay, so this one you have 5 carbon kan. Cyclic ni memang dia terpisah dengan open chain. Okay, you either refer this as a parent ataupun you refer the open chain as a parent. So you kena decide. Okay, nak decide macam mana, kita go for the number of carbon. You have to count the number of carbon. Okay, for the cyclo, you have 5 carbon. For this one, you have 3 carbon. So which one has more carbon in it? Of course lah, the cyclo. Okay, so therefore it will become the parent. So dia jadi cyclopentane, and this one will become the substituent. So dia become propyl cyclopentane. Same goes to this one. Okay, so this one you have 6 carbon. But this one, kalau dia sebagai parent, 1, 2, 3, 4, you have only 4 carbon. So obviously, the 6 carbon wins. Okay, so it is in cyclic form, therefore it is cyclohexane. And this one will become the substituents. Okay, so it ends with YL. So in this case, it is Butyl. Or you can also name this as based on systematic naming. Macam mana? Tadi dah belajar kan? Okay. Okay, what if? What if you ada macam ni? One, two, CH2, CH2. CH3. This one. Okay. 3 carbon. This is also, the open chain is also having 3 carbon. So you nak go for mana? Nak go for, nak parent saya tengah cerita pasal parent Nak go for cyclo ke nak go for open chain? So that's why dia cakap dekat sini, if the number of carbon atom in the ring is equal or greater. This one greater lah. Of course, kita akan choose the cyclo as the parent. But if you have same carbon for open and cyclic form, so you would still go for the cyclic. Cyclic will have the will become the parent. Okay, alright. So it will be named as cyclo. Dia ada berapa carbon? Cyclopropane. Okay, do not forget the cyclo. Okay, guys. If you without the cyclo, it will become propane. So it's totally different from cyclo. Okay, it will be cyclopropane, and then this one we have 3 carbon, right? So very straight chain, just 3 carbon. So we have a carbon. So assume this one as carbon number 1, number 2, number 3. So it is 1 propyl cyclopropane. Okay. So kalau kita ada contender dia 3 lawan 3. So kita go for the cyclic form as the parent. Okay. Alright. So ni obvious lah. Okay, you ada 4 carbon, 1, 2, 3, 4, 5, 6. 6 carbon. Okay, ini straight chain dia. Kalau kita consider dia sebagai parent. Straight and continuous. Longest and continuous. You would have 6 carbon. So 6 carbon versus 4 carbon. Okay, of course lah 6 carbon yang akan be chosen as the parent. So nampak tak? So 6 carbon is the open chain. So that's why it is called hexane. So this one will become the substituent. So bila dia jadi substituent, it should end with YL. Simple je, sama je step dia. Dia akan jadi substituents. Same goes to this one. You have 4 carbon versus 3 carbon in the for the cyclopropane. Cycloalkene lah. Okay, alright. So of course 4 carbon wins. So the parent name should name after the open chain, which is the butyl, and then this one will become cyclopropyl. Okay, alright. Numbering pun sama. You would go for the lowest numbering possible. Okay, you kena try and error lah. Kena try and error. Okay. Alright, so 1, 2, 3. Ini pun kalau you start from here, 1, 2, 3. So either one pun you akan dapat 1 dengan 3. How about this one? Ni maksudnya you start from here lah. Ataupun bukan ke sini bukan ke bawah sini. Bukan ke sini. Salah, bukan. Kena try and error. Okay. This one kalau you start from here going down, you akan dapat 1 dengan 5. So 1, 3 and 1, 5, which one we would consider? Of course lah, the lowest number possible. 1, 3. Okay. Right. Another thing that you have to consider adalah bila you check, you try numbering lah to get the lowest number possible kan. This one you start from here. Yang this one pula you start from here. Okay, kita prioritizekan the substituents. Either way pun you get 1, 2. This is also 1, 2. It's just that for this one, ethyl will be carbon number 1, methyl will be at carbon number 2. This one terbalik pula. This one, methyl, carbon number 1, ethyl at carbon number 2. This still 1, 2, it's just that location tu. 1 methyl, 1 ethyl. Ni nak pilih mana? Numbering is not a problem now, tapi who would have carbon number 1, who would be assigned with carbon number 2? In this case, we are going to be based on alphabetical order. Okay, kan banyak sangat possibility kan, probability yang might happen during the naming tu. Nampak tak? IUPAC dah siapkan dia punya step by step process. If in case, okay, ni 1, 2, tapi ni 1 dekat ethyl, 2 dekat methyl, but the other one terbalik. Tapi still 1, 2. Okay, alright, in that case, we would consider for alphabetical order. So since E datang dulu, then M, then E should be assigned with the lowest number, with 1 lah, we subject to this example. Okay, so E should be assigned with number 1, M should be assigned with number 2. So this is the correct one, this is the incorrect one. Okay, so don't name based on this one. Right? So the rest are basically the same lah. You have to try and error, like I said. Okay, you have to consider a lot of things dekat sini. Okay, you numberkan macam ni. 1, 2, 5. 1, 2, 5. But this one you dapat 1, 3, 6. You nak pilih yang mana? Okay, so go for the numbering dulu. Bila numbering dah settle, then baru you go for the substituents. Macam yang case yang tadi tu kan. Oh, ini pun 1, 2, ini pun 1, 2. Then baru you choose alphabetical order. But this one 1, 2, 5, ni 1, 3, 6. So kita akan obviously choose the lowest one lah. 1, 2, 5. Kena try and error, okay guys. You kena try, okay, what if kalau start 1, 2, 3 macam ni. Ataupun you start from here 1, 2, 3. Ataupun you start ke bawah 1, 2, 3, 4. Banyak sangat possibility. Okay. Alright. So, ni lah. Itu dia punya contoh dia. Okay, last but not least. If halogens are present, treat them just like alkyl group. Okay, if halogens are present, treat them just like alkyl group. Dia macam, if you have halogen in alkenes, okay, in cycloalkenes or in alkenes, you would treat this halogen as if dia adalah other alkyl group like methyl, ethyl, propyl and whatnot. Okay? So bukan you prioritisekan dia. Bukan, bromine or chlorine. Okay, dia must get the lowest number possible. Dia mesti kita prioritisekan dia. No. Okay, you don't have to do that. Kita akan based on the lowest numbering possible. Tapi when it comes to, kita kena choose, macam tadi kan, nak choose for, okay, ini 1, 2. Ni pun 1, 2. Tapi this one bromine sebagai nombor 1. This one bromine sebagai nombor 2. So kita akan pilih yang mana? In this case, we will go for alphabetical order. Faham? Bukan kita prioritisekan dia. Bukan. Kita tak prioritisekan dia. Kita numbering dia sama macam kalau ini adalah methyl. Nada methyl. Okay, kita number dia sama. It's just that ni kebetulan dia punya B tu, B come first compared to M kan. So that's why bromo, B should be assigned with carbon number 1. Whereas methyl should be assigned as carbon number 2. Okay, so imagine kalau you ada, katakanlah we have hexane, right? So we have methyl group here. Kalau saya buat ni, ini maksudnya methyl awak tahu ini methyl tau. Kadang-kadang kalau dia buat, kadang dia buat CH3. Kalau dia tak buat CH3, awak kena tahu ini, this is carbon ni. Ni carbon ada 3 that is in skeletal form. Skeletal form. Katakanlah saya buat macam ni. CH3, this is CH3 and then here we have Br. Mana letak Br? Sini ke, sini ke? Tak sinilah. Okay, you kena try numbering. Okay, katakanlah you buat 1, 2, 3, 4. You akan dapat 1, 3 dengan 4. Katakanlah you start numbering from here. This one. Okay, this methyl group. 1, 2, 3, 4. You akan dapat apa? 1, 2 dan 4. 1, 2 and 4. Kalau you start from here, from this one, ni kita try and error Ni 1, 2, 3, 4, 5. You akan dapat apa? 1, 3, 5. So mana yang paling kecil? Ni lepas you dah try lah semua Ini out, ini out. You akan dapat 1, 2, 4. Maksudnya you kena start from here. Methyl, 1, 2, 3. This one. 1, 2, 3, 4. Okay? So, bromine akan jadi nombor 5. Nombor 4. Bromine akan jadi nombor 4. Adakah kita prioritisekan the bromine? No, kita akan prioritisekan everybody should get the lowest number possible. Tapi bila kita nak name them, nak put them into full name, kita kena follow alphabet lah kan. Bila nak masukkan, dah buat numbering and then nak jadikan nama, then kita kena consider for alphabet. So bromine should be named first. So dia nombor berapa? 4 bromo. And then kita ada carbon number 1 and 2. 1, 2, dimethyl, right? Ni cyclo apa ni? Cyclo hexane. Tu maksudnya if halogen are present, treat them just like alkyl group. Okay? So sama macam kita treat yang lain-lain tu. Kita tak prioritisekan dia unless when it comes to this situation where we have the same location of the substituents, then kita akan go for alphabetical order. Okay? Alright, nak buat nombor berapa? A, B, C, guys?
Medium.
A.
A Okay. Sekejap je.
Dengan C.
Ha? C? Nak A ke nak C?
Dua-dua.
Apa? Saya pula buat apa tadi kita bincang apa? Oh, tadi kelas tadi pun kita buat dua-dua. Okey, tak apa. Buatlah dua-dua. Okay? Alright. So, kita go for C dulu lah. C very obvious. Okay. So, the straight chain is this one. Kita kena count the number of carbon, how many we have in it in this straight chain, in this open chain. 1, 2, okay, 1, 2, 3, 4, 5, 6, 7. 7 carbon. As for the cycloalkene, we have 5 carbon. So 5 versus 7, okay, 7 wins. So 7 carbon will be the parent. So parent for this 7 carbon is known as heptane. Okay, and then we are going to assign numbers. Okay, the number. So obviously kita akan start from here lah, not from here. Sebab dia paling dekat dengan substituents. Okay, so 1, 2, 3. At carbon number 3, we have this cyclo. This is 5 carbon kan? Cyclo, don't forget the cyclo. Cyclopentyl. So 3 cyclopentyl. 3 cyclopentyl heptane. Okay, all right, B. Okay, B, obviously this will be the parent. So we have 6 carbon. Then, so it will be cyclohexene. This is the name of the parent, cyclohexene. Okay, so kita kena try and error lah. Bukan ini kan sebab dia sama kan. Dia punya gap dia tu ada 1 carbon setiap satu. So either way pun you still akan dapat numbering yang sama. You start from here. Kata you start from here. 1, 2, 3, 4, 5, 6. You akan dapat 1, 3 dengan 5. Betul tak? 1, 3, 5. Kata kalau you nak start from here. This one. Pakai colour merah pula. From this one. 1, 2, 3, 4, 5, 6. Still you akan dapat 1, 3 dengan 5. Sama juga kalau you start from here. This will be your carbon number 1. Okay, try yang lain. Katakanlah kita nak start here sebagai carbon number 1. Tempat lain. This one. Ni. Carbon ni. This carbon as carbon number 1. So saya nak ke bawah. 1, 2, 3, 4, 5, 6. So saya akan dapat 2, 4 dengan 6. Bapak pula. Bapak besar nombor dia tu. 2, 4 dengan 6. So, kalau you start dekat tempat lain pun yang tak ada substituent tu, you will get this value. You will get this numbering. Okay. So, 2, 4, 6 dengan 1, 3, 5, you would, of course lah, we would choose 1, 3, 5. Okay, so kita clear everything off first. Sebab dia gap yang sama kan antara setiap substituent tu ada 1 gap. Okay, so katakanlah, okay, obviously, okay, kita ada 1, 3, 5. Either way pun kita start dekat sini ke, kita akan 1, 3, 5 juga. So, kita akan prioritize. Nak pilih siapa yang dapat nombor 1, nombor 3 dengan nombor 5 tu. In that case, we have to prioritize in terms of alphabetical order. So, we will go for this one. Number 1, you nak pergi ke sini pun boleh. Nak pergi ke sini pun boleh. Why? Because Dua-dua pun methyl group. Unless lah sini ethyl. Okay, kalau sini ethyl, you go here. You would start the numbering from bromine and then to the left. 1, anti-clockwise. 1, 2, 3. Because this is ethyl. Contoh, ini methyl, saya tukar ethyl. This is methyl. Still 135, tapi kita kena prioritize alphabetical order. Okay? Alright, so itu contoh. Ada contoh. Alright, so 135, so 1, tadi apa? Cyclohexane. Number 2, number 3, number 4, number 5, number 6. So 1 bromo. Then number 3 and number 5, right? 3, 5, so kita ada dua number di situ, so di. Okay, don't forget the di. Kalau ada 3, then it should be tri. Okay, di, methyl, cyclohexane. So this is the name for E. Okay. Right. Yang lebih tu you buat sendirilah. Okay, so that is for your practice. Okay, and finally, okay, we have come to this reaction part. So this is very important. Okay, so we start with alkenes. So the good thing about alkene is that it only alkene has only one reaction. Okay, later on we have alkenes. So once we have done with alkenes, we have alkenes. Alkenes have more than one. I think we have like 5 reactions for alkenes alone. So every functional group has its own reaction. Yang itu yang critical part tu. Okay, so luckily we start with alkenes. So this is like to give you an idea on the mechanism, on the arrow used, on the product produced, okay, on the steps. Right. So the reaction that alkenes undergoes, okay, will be the free radical substitution of alkenes. Okay, free radical substitution. Okay, the reason it is substitution, not addition, because there's no double bond in alkenes. All single bond. Like for example, this is methane, kan? As you can see, okay, all of them are single bond. Okay, we don't have double bond for alkenes. Okay, that means it can only be substituted. Kita tak boleh tambah bond lagi. Nanti dia jadi 5 bond. Dia dah overrule. Dia dah tak follow the octet rule. So we cannot simply add bond to the carbon. Okay, alright. So what we can do is to substitute one of the hydrogen. Let's say we want to substitute one of the hydrogen with halogen. Then that's why it is called substitution ataupun replacement. Okay, and then it's not a normal substitution. It must be the free radical substitution. Why is it must? Why is it apa nama tu free radical? Okay, why is it free radical substitution? Kenapa tak the normal substitution? Because why? Because this alkene is already very stable, guys. They're very stable, therefore they're very unreactive. It's like our noble gas. Contoh lah, noble gas is the most stable form of element in the world. Okay, bila dia dah stable, it won't react with anything. Won't react with anything. Kan? Same goes to alkenes. Okay, dia dah stable. So it is very unreactive. Alkenes are very relatively unreactive because of the absence of functional group. So alkene does not have functional group. Dia tak ada double bond, dia tak ada halogen, dia tak ada apa dalam tu. Dia basically dia C dengan H. And the thing about this C dengan H punya bond, they are very strong. Dia strong. Maksudnya dah lah dia dia strong due to this dia stable due to this strong carbon and hydrogen and C carbon bond. S carbon and carbon sigma bond. Okay, basically all sigma bond lah. So basically dia tak mau react dengan siapa-siapa pun. But we still want to substitute one of the hydrogen of the alkene with something else. Kita nak kacau dia juga. So how can we replace one of the hydrogen with something else? For example, with halogen. Okay, so kalau kita nak kacau somebody that is already in very stable form, you have to put extra energy, kan? Logically speaking, you have to put something that is very unstable to disturb this stable compound. Okay, you ada kawan you yang very calm, very stable, kan? And then you letakkan dengan kawan you yang serabut, yang panik tak tentu pasal, lama-lama dia akan terpengaruh juga sikit sebanyak dengan kawan. Okay, sikit sebanyak tu mesti ada. So you kena put something with that idea in mind. Okay, therefore we put something that is very reactive. Okay, because this reactive species will then react with these alkenes. Okay, so that's why dia kena dalam this free radical form. Orang yang nak attack this alkene must be in free radical form. Tak boleh orang biasa saja. Okay, because the reaction will not happen. Okay, so like I said, at room temperature, if you place the alkene compound with Cl2 molecule, the normal Cl2 molecule or Br2 in the dark, okay, there will be nothing happening. No reaction will take place because this is something yang very stable as well. Okay, so it won't attack this alkene to produce any product. Okay, therefore we need support lah ataupun help from external source, okay, which is the UV light. Alkene undergoes free radical substitution with halogen, okay, Cl2 or Br in the presence of UV light. Why do we need UV light? Because this UV light, the purpose of having this UV light is to break the bond between the Cl kan Cl chlorine dengan chlorine tu, they break the bond, okay, and they break the bond and produce the free radical. UV light is important in order to produce free radical. When free radical is produced, it will definitely become unstable and very reactive, and it will attack anybody yang ada dekat dia, including the alkenes. Okay, alright. So the hydrogen atom is in alkene will be successively replaced by chlorine or bromine atom to produce halogenated alkene. So once we have the free radical, okay, all the hydrogen in the alkene can be replaced with the free radical, the chlorine just now, the bromine just now. Okay, so that's the idea of it lah. Okay, imagine, so this is methane, so this is the equation. Okay, so we have the chlorine. Basically, we want to replace one of the hydrogen with chlorine. We want to add the, we want to replace the hydrogen with chlorine, but we need UV light in order to replace the hydrogen. So later on, this is the product form. It's just a replacement reaction, but it won't happen without the UV light. Okay, keadaan tu mesti berlaku dengan adanya UV light. Okay, this is the what we call that, dia punya general equation for free radical substitution. Okay, you need to have this UV light. Okay, in detail, this free radical substitution actually requires 3 steps. Ini general equation, okay guys. Tapi kita tak nampak apa-apa pun yang berlaku. Maksudnya what is the mechanism? What actually takes? What's the steps? Okay, the step-by-step process in order to produce the final product, in order to replace the halogen into the alkene. Kita tak nampak kan daripada this equation, this general equation. So actually, we have 3 steps, and these are the mechanisms that you need to know, okay, for the free radical substitution of alkene. It is first proceed with the initiation step. The reason it is called initiation, dia pemula. Okay, remember, you need to have something yang very reactive in order to attack the alkane. Because alkene is now very stable. So in order to attack this stable form of compound, you need to produce something that is very unstable, which is the free radical. So this initiation step is to create the free radical. Okay, all right. So we would create the free radical by having the halogens. You can use chlorine or bromine. Okay, all right. In the presence of UV light. So what actually happened is that this bond will be broken down and the electron, so they share the same, they share 2 electron each, and bukan, they share 2 electron, which each one of them contribute 1 electron each. Okay, each one of them contribute 1 electron. Okay, so bila dia break this bond, so one of the electron will be returned back to its owner. So this is, remember, this is known as homolytic fission. Nampak tak arrow dia, kepala dia, dia pakai satu half-headed arrow. Okay, half-headed arrow. So dia belah, so pulang balik kepada owner dia. So this arrow is very important. This is what we call mechanism. You have to show the mechanism, what actually happened. So kalau you tunjuk equation je without the arrow, that is equation. Tapi kita tak tahu what actually happened. Okay, alright. So benda yang berlaku adalah this UV light will break this bond and the electron will be returned back to the owner. And jadilah begini. Ini nampak tak? This is what we call odd electron species, guys. Odd electron species. This is what we call, this is also known as free radicals. So once we have produced these free radicals, okay, in the initiation step, so in the initiation step, we would produce the free radicals, okay? So this later on will be used in step 2, the propagation step. Okay, will be used in step 2. So, the free radical just now yang kita produce tu, bukan producer saja sebab kita nak gunakan the free radical to attack the alkene. To attack molecule to produce another free radical. So, bila free radical, like I said, free radical ni, dia akan attack anybody yang ada di berdekatan dengan dia. Sebab dia tak stable, dia very reactive. So, bila dia attack orang tu, the reason dia attack because dia nak jadi stable. Bila dia attack, dia jadi stable. Tapi orang tu pula yang jadi tak stable. Dia macam zombie. It's like zombie. Okay? So, this one just now from step number 1. Remember? Tadi kita ambil, kita pakai. So, this will attack. So, this is arrow number 1. Nampak tak? Still using half-headed arrow. Sebab yang terlibat hanya satu elektron. Okay? Maksudnya dia tak cukup. Dia bukan bagi 2 elektron. Okay? Alright. So, attack this first one. Okay, dia nak attack hydrogen sebenarnya. So what actually happened, this bond here from the alkane will be broken down. Macam biasa bila dia break, dia akan return back to the owner. Both electron, the 2 electron will be returned back to the carbon and 1 to the hydrogen. It's just that the hydrogen later on will combine, okay, will combine directly with Cl. Dia break, return kepada owner masing-masing, and H ni dia extended sikit because this later will combine with Cl, becoming HCl. Dan tinggallah yang seorang ni sebagai free, dia pula jadi free radical, nampak? Okay, so this is the first step of propagation. In the propagation, we have 2 steps. Okay, to produce the free radical of the alkane. And this later on, kita akan guna, ni step number 1, step number 2. Guna balik dekat sini. Okay, so dia akan attack the Cl2 molecule. Mesti ada soalan tanya, madam, kenapa? Tadi kan dah guna Cl2, kenapa ada lagi Cl2? Jangan ingat bila dalam reaction tu ada satu je molekul Cl2 Ada banyak molekul Cl2 yang lain. Okay, so dia hanya perlu create satu free radical saja. Kalau create banyak, of course lagi banyak attack dia tu kan. So, hanya perlu create some of the free radicals so that the attack will later on follows. Okay, alright. So, this one yang tadi from here, carry forward, carry ke bawah ni, attack the Cl. So, dia attack. Arrow dia macam biasa single headed arrow, single half. Number 1, okay, this one macam biasa will be broken down. So return kepada owner masing-masing. And then ni pun return tapi extended a bit. Okay, because dia akan form bond. See? This one. Ni bond yang terbentuk. Dan terjadilah satu lagi free radical. Propagate. Dia akan berganda. Okay, bila dia dah stable, orang lain pula jadi free radical. So that would be the byproduct of this propagation step. But as you can see, nampak tak produk yang kita nak produce? We want to replace one of the hydrogen with Cl. See, kita dapat produce kita punya produk yang kita nak. This is what we call mono substitution. Kita replace one of the hydrogen with one Cl. Disubstitution, that means two of the hydrogen will be replaced with Cl. Okay. But please take note that for propagation, you have 2 steps. Okay, in replacement, you have to go through 2 steps in order to replace 1 Cl into the alkenes. Kalau you nak ganti 2 Cl, you nak masukkan 2 Cl, that means you have to have 4 steps. Okay, and you nak ganti 3, you kena ada 6. Dia gandaan 2 lah. Okay. Alright, tapi you kena jadikan dia cerita So dia kena start from here. So the attack of the free radical first, number 1. And then this one will be broken down. Okay, and then return to this one number 2, this one number 3, and number 4. Return back to its own. So that you dapatkan chronologies and it is easier for you to memorize. Kena ada penceritaan guys. Buatlah alien attack ke, macam tu ke, tak kisah. Okay, sebab itu yang sebenarnya will be helpful in terms of memorizing. Okay, next. We have to terminate the reaction. Let's see. Okay, you just want to replace one of the hydrogen with Cl. Now you have done it. Okay, you have replaced one of the Cl with one of the hydrogen with Cl. You have done it. Okay, you want to stop the reaction. How would you stop the reaction? Okay. So you need to stop this reaction. If not, dia akan ganti all the Cl. Boleh, that is possible. Because as long as we have free radical, okay, this free radical will keep on attacking. So we need to end this reaction, okay, by having the 3rd step. It is called termination step. Okay, so this termination step is when the 2 free radicals combine to form a molecule. So the target is to remove all the free radicals. So when we have free radicals in the reaction, it will keep attacking the molecules, okay, and producing more free radicals. And so we don't want that to happen. So this termination is when you react the free radical with free radical. Okay, so basically bila dia react dengan free radical, dia akan produce a neutral molecule. Okay, so imagine in the reaction we have all these possibilities. Okay, sebab ada kemungkinan di dalam tu ada Cl free radical, ada juga free radical of the alkene. Okay, alright, so option number 1 ataupun possibility number 1, the Cl free radical will combine with the Cl free radical. So, dia punya arrow again, half-headed arrow, combine, di attack. Maksudnya di combine and form bond. So, this is the bond that form. The second possibility is between CH3 and Cl. So, this is our targeted product, right? This is our targeted product. 1Cl. Okay, alright. So basically the free radical of alkene react with the free radical of Cl. Okay, you have to combine these two. It will produce this bond, produce our targeted product. Another possibilities is when CH3 dengan CH3 combine. So this will be produced. Ethane will be produced. Okay, so these are the 3 possibilities that can happen during the termination. So the product of termination will be a neutral molecule. Okay, a neutral molecule. Right? Okay, any question related to that, guys? Okay, if there's no question,
Tak
maybe
ada,
you can.
madam.
Tak ada Okay, clear So basically free radical substitution, if the question asks for the type of reaction that alkenes undergoes, you kena mention free radical substitution. If you just mention substitution, no marks will be given for that because it's not normal substitution. Okay, it's not normal substitution. Dia tak boleh simply ganti macam tu. It need to be in free radical form. Then only can substitute. That's why it need to be named full as free radical substitution. Okay, all right. So please take note on that. Okay, let's try on checkpoint 10. Okay, kita nak apa? Kan kita dah belajar tadi. Okay, let's apply. The bromination of ethane is a free radical reaction. Okay, we are talking about alkene, so obviously the only reaction for alkene is free radical substitution. Bromination is a process to replace the hydrogen with bromine. Okay, you can either replace one or you can replace all of the hydrogen with bromine. So that is called bromination. Okay, the question asks to write the mechanism for the monobromination. Monobromination. Okay, monobromination of ethane. That means you just have to show for one substitution of the bromine. Tak perlu nak tunjukkan semua hidrogen tu, hanya mono substitution. Maksudnya si BR akan masuk, satu BR replace one of the hydrogen. That is what we call mono. If we have two BR masuk, then it is di substitution. At once, ni serentak. Kalau dua masuk serentak, then it is called di. Okay? Alright. Okay. So, jom buat. Okay, so dia kata write the mechanism for the monobromination of ethane. Okay, ni dia tak specify. Okay, sometimes in the question can specify. Okay, write the mechanism, the propagation mechanism of monobromination of ethane. Then you would only write the mechanism for the propagation step. Exclude the initiation and the termination. Depends on the question. Since for this question, it did not mention, it did not specify whether apa dia nak initiation ke propagation and termination. Dia tak specify. So we have to give all. Okay. Alright. And then do not get confused by the term used here. Right is in for this case represent the draw. Represent draw. Okay, it's just that for organic chemistry, untuk nak mechanism ni, dia guna term write instead of draw. Tapi maksud tu draw. Okay, bukanlah write tu maksudnya you buat karangan. First, the initiation step, will that? No. Okay, in chemistry kita jarang buat karangan. Kita guna scheme. Okay, we use reaction scheme, reaction equation, formulas to explain our answer. Okay, so bila dia tulis write tu, janganlah awak pergi buat karangan. Bukan, you kena buat this, all these steps ni. Tengok. Okay, start. Okay, let's have initiation. Saya buat kata lah initiation, pendek je kan. Initiation. Okay, initiation. So look at the question carefully. So dia kata bromination, that means you have to use bromine, BR, not chlorine. Just now the example we use chlorine, but you have to refer to the question. Okay, don't forget the UV light. So mechanism, okay, dia bukan nak equation. Kalau equation, you tak payah tunjuk arrow. But mechanism represent the step-by-step process. You need to have the arrow. Tak ada arrow, hilang dah 1,5 markah dekat situ. Okay, alright. So this one will be broken down due to the presence of UV light. So each electron will be given back to the owner. Okay, pakai half-headed arrow. Okay, guys. This is very sensitive. If you use the full-headed arrow, again, salah. Sebab dia belah, satu elektron diambil dan diberi kepada bromine. Satu elektron saja terlibat kan? So, we use half-headed arrow. So, we would produce the free radical. settle for the initiation. Okay, now let's proceed to apa nama propagation, guys. Propagation. Okay, we know that propagation, we have two steps. Okay, so let's use the free radical produced from the initiation. Okay, all right. So I would normally start from the alkene itself. Okay, so ethane kan. So kalau nak bagi nampak everything, you can also use skeletal. Okay, Okay. Right, so basically we want to replace one of the hydrogens, this one katakanlah with bromine. Okay, so bromine from the initiation step just now, this one. Okay, so the bromine will attack, the free radical will attack the hydrogen. And this hydrogen that is attached to the carbon, okay, the bond will be broken down. Dia akan break and the electron will be returned back to the owner. So pulang kepada hydrogen and the other one will be returned to the carbon. Kena ada 3 arrow dekat situ. Okay, return hydrogen, hydrogen terus je form bond with bromine. Okay, so this will be the product form CH, KH, CH, ada dot. Okay, ayah. Okay, we have dot here. So this is dot tu buat clear buat make sure it is clear Don't just simply put macam dot, very small dot. So kita tengok ni ada ke ataupun dengan scannya nampak macam gelap lagi lah tak nampak. Make sure you bulatkan betul-betul. Okay, alright. And then plus dengan this one dah remove out kan HBr. This is a byproduct form. Okay, so this one will be carried further for the second step. Okay, kita akan pakai this free radical to produce our final product later on. Okay, H. Okay, and then another Br2 molecule. Okay, dia akan attack orang yang stable lah. In this case, this molecule, Br2 molecule, okay, attack. Bila attack, ini bond akan broken, return back to the owner. Okay, this one will directly combine with the alkene free radical. Okay, right, so and this is the mono substitution of bromine into ethane. Okay, and don't forget the free radical produced from this attack. So dah dia kata mono kan, nak sekali kan. So satu lah dah ganti kat situ. Sekali penggantian. Nak masuk lagi sekali, then another 2 steps of this propagation. Okay, alright. Next, termination, guys. Termination. So let's proceed here. Termination. Terminate. So basically, this is termination. This is our product. This is our targeted product. Okay. Alright. So, what could possibly, what can we, apa nama tu? What are the possibilities of free radical that we may have in the reaction? Okay, paling senang Br. Br dengan Br. Okay, alright. So these two will form bond, will attack one another and form bond, and producing Br. Okay, another one is CH3. Saya pendekkan supaya senang. So this one, another free radical, react with Br also. Possibility number 2. Okay, right. Attack and form bonds. So we would have the CH3, CH, Okay, and the last one we would have this one. CH3, CH, okay, react with CH, CH3. Okay, free radical. So this one will react with one another to produce butyl. Butyl lah, combine empat all the the 4 carbons. Okay, we would have butyl. So buat sini lah. Saya buat skeleton. 2, 2, 3, 2, 2, 3, 4. Jadilah. Buatlah dalam expanded. Okay. Siap. This one. Okay. Saya nak kena masuk juga alkene sikit sebab nak samakan dengan kelas ni sikit. At least nomenclature. Okay, any question related to reaction of alkenes just now? You guys clear? You guys following so far?
Follow.
Follow, seorang je, awak the rest. Yeah.
Okay, madam.
Right, okay, very good. Okay, good. Okay, remember kan saya suggest, I highly advise you to prepare your mind map. Okay, kita dah settle for alkenes. Okay, dah settle for alkene. So, dah ada reaction. Now, kita dah boleh cross alkene from our list. Delete. Next, we move on to alkenes. Okay. So, dia punya step sama. Dia akan start nomenclature and then kita ada reaction. Nomenclature, naming and then reaction. Nomenclature, naming, naming and then reaction. So, we are done with alkenes, guys. Okay, now we move on to alkenes. So do something about alkenes. Okay, sementara kita masih at the beginning of the topik lagi ni, you cari masa untuk cover. Nanti kalau you dah tengah-tengah, dah hujung, bukan too late, masih ada masa tapi it's a lot of work lah. Banyak kerja lah dekat situ. Okay, of course you akan kena memorize reagent, condition and what not kan. So you mesti make sure that you seiring dan sejalan. Okay, kalau you belakang sangat, takut tak tercatch up tu yang dia let go, dia lain dah perfect, tiba-tiba organic chemistry je tak ni. Kan sayang. Sikit je lagi guys. Tinggal lagi 3 minggu je lebih kurang. Tolak raya. Okay, alkenes. Bismillahirrahmanirrahim. Alhamdulillah, we have finally covered for alkenes. Okay, next, let's move on to alkenes. Kita dah far behind sebenarnya from the schedule. Okay, structure of alkenes. Basically, alkenes we have double bond. Okay, we have double bond, C, double bond C. And please take note that this C double bond C, the hybridization type is sp2. Okay, if C single bond C, the hybridization type is sp3. For C double bond C, the hybridization type is sp2. Okay, takut keluar dekat objektif the characteristic of C double bond C, sp2, sp3 tu confuse. Okay, moving on, straight chain of alkene. Okay, example, so this is ethene, the application of ethene. I've mentioned this during our lab session last time. Ethene, or also known as ethylene, is a natural plant hormone and used in the agriculture to force the ripening of fruit. Okay, so this gas of ethylene is used to ripe the fruit. Naturally, memang dekat pokok tu memang ada this gas. And it is used to make, this ethene can also be used to make polyethylene. Okay, so ethene is the monomer. If we combine further more of ethene, it will become polyethylene. Okay, so polyethylene is a polymer lah. Okay, other than ethene, we also have propane. Propane is also alkenes, but ada double bond there. Okay, so it is used to make polypropylene, another polymer. Okay, another polymer. Okay, that is just intro lah of alkene. Okay, okay, so like cycloalkane just now, we also have cycloalkenes. Okay, that means in the cyclic form, we have at least one double bond in it. Okay, at least we have one double bond. So like this one, we have 3 carbon, but we do have one double bond in it. Therefore, it is named as ENE. It ends with ENE. Cyclopropane. Don't forget the cyclo because this is cyclic form. Okay, all right, cyclopropene, cyclobutene, cyclopentene, cyclohexene. This one 6 carbon, this one we have 5 carbon, this one we have 4 carbon. Okay. Okay, naming, nomenclature. Nak settlekan nomenclature so that tomorrow we will start with reaction right away. Okay, straight chain of alkene. Okay, basically dia punya step dia sama. We will adapt the same step that we have learned in hydrocarbon last time. It's just that ada few things that I would like to highlight. So kita dah start masuk functional group. Alkene is considered as homologous series kan. Dia punya functional group is C double bond C, right? Okay. When you try to find the parent hydrocarbon chain, you must make sure that the functional group should be included in the parent chain. Jangan ralik sangat nak cari dia punya the longest, tertinggal dia punya functional group. Okay, even though you ada parent chain yang sangat panjang, tapi this parent chain, dia tak include the double bond. So you won't use that as your parent chain. No. Parent chain mesti yang panjang, continuous dan mempunyai functional group. Okay. Okay, contohnya macam ni. Okay, so this one 1, 2, 3, 4, 5. 5 carbons kan? But kalau you go for this one, 1, 2, 3, 4. You ada 6 carbon. 6 carbon. Tapi this is wrong because it did not include the C double bond C in the parent chain. So this is wrong. So jangan gelabah sangat nak cari the longest parent chain. Okay, you have to consider for the functional group as well. Make sure that the functional group is in the chain. Okay, right. So itu satu lagi yang you kena consider, and then number the carbon atom. Okay, numbering. The target is to make sure that the functional group should have as lowest number as possible. Okay, macam mana nak tahu? Kena try and error lah dekat situ. So contohnya, the same molecule here, so kita akan ada C3 dengan C4 kan, double bond kan. So ni option sebab dia duduk dekat tengah. This is our option. Lagi satu option, C3, still C3 double bond. Tapi dia equal distance. Nampak tak equal distance kat sini? So kita nak go for substituent, then kita kena go for substituent, the lowest number for substituent. Sebab either way, kalau kita start daripada sini ataupun start daripada sini, you still will get C3, carbon number 3 as the double bond. Carbon 3 and carbon 4. Same. Okay, and then next we have to consider for the substituent. Try to get the lowest number for the substituent. So therefore kita kena start dekat sini. Sebab kalau dekat sini kita akan dapat carbon number 2. This one kita akan dapat carbon number 5. So high number. So tak boleh. Okay, so those kind of thing lah you kena consider for double bond kena the lowest number possible. Okay, and then baru you go for substituents. Kadang-kadang dia overlap dekat situ. So you kena consider both kadang-kadang. And sometimes it involve alphabetical order pula. Benda-benda macam tu. Okay. So you may go through it lah. Basically dia punya sama tapi prioritize the double bond. Okay. Then the substituents. Right. Right, the full name. Full name macam biasa. Okay. So you should end with E and E. The rest, numbering, alphabetical order, everything should be the same as what we have learned earlier. Okay, guys. Alright. So sama. Sama ni pun sama. Use prefixes. Repeat for other substituents. You need to use prefixes. Okay. Like this one. Okay, ni tak ada prefix digunakan. Macam ni kita ada 2 methyl group, right? So don't forget to use di. Okay? Okay. Cycloalkenes. Okay, cycloalkenes. It is very much the same as what we have for alkenes, normal alkenes just now. Okay? It's just that. Ada je, it's just that. Yeah? Okay. This one sebab dia cyclic kan? Dia cyclic form. Okay. Dia punya syarat dia paling tersyarat sekali. In the cycloalkenes tu, the double bond should be assigned as carbon number 1 and number 2 only. Dia tak boleh 3, 4 macam yang ni kan tadi kan? Boleh 4 octene. Maksudnya the double bond is located at carbon number 4. Sebab dia open chain. But for cycloalkene, for cyclic, syarat dia, double bond should be between carbon 1 and carbon 2. That's the syarat. Okay, so whatever you do, prioritize the double bond in the cycloalkene as carbon number 1 and carbon number 2. Okay, contohnya, you ada macam ni kan, tak ada substituents, you ada 1 kat sini. So ini akan jadi 1 atau 2, 2 atau 1 lah maksudnya sebab dia tidak ada substituents. Okay, what if there is a substituents? Okay, there is a substituents attached to the cycloalkenes. Syarat pertama tadi masih terpakai. The C double bond C should be assigned as carbon number 1 and carbon number 2. It's just that now we have methyl group attached to one of the C double bond C kan. So who will be assigned as carbon number 1? Of course lah yang pegang substituents. Okay. Alright, so this is quite obvious lah. 1 methyl cyclopentene. Don't forget the E and E. But this one you don't have to specify location of the double bond because it is understood that dia mesti carbon number 1 dan carbon number 2. So macam tadi you kena specify dekat mana double bond tu 4 octene at carbon number 4. For this one you don't have to specify. Just specify for the substituent 1 methyl cyclopentene sebab it is understood that the double bond must be carbon number 1 and carbon number 2. Okay, let's look at this one. See? Nampak tak ni? 1, 2. Dia mesti 1, 2. Okay, dia 2 orang ni mesti 1, 2. So either you nak start dekat sini 1 ke 2 ke, itu you kena try and error juga. Okay, kalau you start from here 1, 2, 3, 4, 5. Sama juga kalau you start from here 1, 2, 3, 4, 5. Sama juga. Tapi kenapa kita kena start from here? Bukan ke sini. Sebab apa? Sebab, okay, cuba you tengok Kalau you start from here dengan here pun, you akan dapat 3 dengan 5. Ke kanan ni, you dapat 3, 5. This one pun, you dapat 3 dengan 5. Sama sahaja. It's just that, satu ni ethyl group, satu methyl, the other one is ethyl. In this case, we have to prioritize based on the alphabetical order. Sebab dia memang dah low, 3, 5. Okay, tapi siapa nak di-assign 5, siapa nak di-assign 3? Kita akan assign based on alphabetical order. So, E come first kan? This is ethyl. This is methyl. So, E comes first. Therefore, E should be assigned with carbon number 3. Okay? Alright, another one. This is very interesting. Nampak tak ini? Okay, so bila, like I said, this double bond should be assigned with carbon number 1 and number 2. Okay, you prioritizekan that one dulu. And if one of the carbon that has double bond tu is attached to the substituents, dia akan automatically jadi nombor 1. Kalau ni nombor 1, ini kena nombor 2. Dia bukan start daripada sini dia bukan begini, bukan. Dia akan pusing. 1, 2, 3, 4, 5, 6. Macam tu. Lantak P lah sini nombor besar. Tak kisah. Cuma syarat dia mesti 1, 2 dan orang yang pegang substituents tu, dia akan di-assign sebagai 1. Yang ada double bond tu lah. Okay, that's why dia punya numbering dia 16. Dimethyl cyclohexene. Prioritize the double bond. Okay. And then kalau double bond tu pegang the substituent, itu jadi carbon number 1. Bukan dia start 1, 2 macam tu and then ni dapat nombor 3. So 1 dengan 3. Bukan. Macam tu, bukan. Not like that. Okay. Okay, so these are the practice, okay, for you to practice at home. And then later on, we have also this checkpoint. Okay, for you to again practice just now from naming to drawing. This one, just now from drawing to naming. Kan, this one. They draw, you name kan. This one from drawing, from naming to drawing. Okay, so try it on your own first. Practice, guys. Practice. Okay, all right. And then later, next slide will be reaction. This one we will start tomorrow. Okay, so please be prepared. I will highly suggest you to go through on your own first. Okay, for the reaction, as you can see, for reactions here, for alkenes reaction. Okay, the slides I've counted just now roughly. We have like 40 slides for alkenes alone, for the reaction of alkenes. So that is quite a lot. Okay, so banyak nak kena dimasukkan dalam kepala otak awak esok. So stand by. Okay, so I highly suggest you to flip through ataupun tengok dia punya tu so that you get an idea of it. Tomorrow I will discuss in detail. Okay, alright. So that's about it for today's lecture. Any question before we end our session, guys? Okay.
No, madam.
Ada
Clear, madam.
Apa? Soalan ke apa tak? Ke bukan tadi?
Clear, madam.
Okay. Okay, alright. So kalau tak ada, balik ni cepat-cepat. Tengok balik, flip balik. Okay, jangan tertinggal jauh sangat. Okay, alright. So that is all. So thank you everyone. So see you tomorrow. Okay, selamat berbuka. Assalamualaikum.
Thank you, madam.
Thank you, madam.
Yeah.
Hey, madam.
Madam.